Now it's time to go ahead and apply logarithms to real life situations. One of those real life situations is when it comes to investing money. So there's the compound interest formula and then there's the continuous compound interest formula. The difference between the two is just how many times something's being compounded. So compound interest, specifically the N, tells you the number of times that you compound in a year. While a continuous compound means it's continuously compounding on the interest, which can be a good or a bad thing. So in both cases, though, the A represents your final amount of money you have, while the P represents the principal amount, meaning how much you put in. R is the rate in both cases, and T is your time. And when we deal with money, we're always talking about time in terms of years. So it's a really important thing to remember is for money problems, it should be years. So you'll notice that the compound interest, the continuous compound interest formula looks exactly like the uninhibited growth or decay formula. They mean the same thing. A is your final amount, P is your principal amount, R is your rate, and T is your time. The one difference, though, is time does not have to be in years when we have an uninhibited growth or decay. So you just follow whatever time or whatever, whether it be days, months, years, whatever it may be. You'll just follow it from the word problem. The last type of problem we're going to encounter are logistic model problems. So often have like a population problem. So P usually stands for your population. The C on top stands for the carrying capacity. And then everything else, like the K is your rate, your T is time, and the A is usually given to you, so it's not necessary to know exactly what that is. But really the big thing to know is C represents your carrying capacity. So let's go ahead and do some problems that are actually from your worksheet and see how this works. So for this one, Jerome will be buying a used car for $15,000 in 3 years. How much money should he invest now so that he will have enough to buy the car if he invests it at 5% compounded continuously? Okay, so that's really important. It's compounded continuously, meaning we're going to use this formula, the PERT formula as I like to call it. So I've got A equals PE to the RT. And we want to figure out what we have to invest. So we're trying to find our principal amount so that we end up with $15,000. So our A is 15,000 while P is the unknown. Our rate is 5%. So I'll put 0.05. And T, remember, has to be in years, and it already is, so it's 3 years, so I'll put 3. So we'll go ahead and put this all in. So we have 15,000 equals P times E raised to the 0.05 times 3. Remember, E is kind of like pi. It's irrational, so it is an actual number. And that's just our way of writing it. Well, since we're finding P and since we're multiplying P by all of this, we can actually just divide both sides by 0.05 times 3. Or E raised to the 0.05 times 3. I think I said that wrong. And that gets rid of that, and you'll just type that into a calculator. And when I type it in, I get $12,910 and about 62 cents. So that's how much he should put in now so that in 3 years he'll have $15,000 in the bank. All right, let's do another one. So this one's also a money problem, so it's going to be one of these first two. But going back to it, how long will it take? So we're looking for time, because it's saying how long, for an initial investment of $1,000 to double at a 3% interest rate compounded quarterly. So we're compounding quarterly, so it's not continuously. So we're going to be using the following formula. And we're going to go ahead and say our A is, so remember our final amount, we're doubling 1,000. So our A is $2,000. Our principal amount is $1,000. Our rate is 3%, so 0.03. Now, n, remember, is the number of times you're compounding in a year. So if we're compounding quarterly, that means it's going to be 4 times in a year. And then t, that's what we're looking for, our time. So let's plug this all in. So we get 2,000 equals 1,000 times 1 plus 0.03 over 4 raised to the 4t. Let's go ahead and clean this up a bit. So first thing, this base with the exponent needs to be isolated. So all this needs to be isolated. So I'm going to divide both sides by 1,000. And then at the same time, I'm actually going to simplify the 1 plus 0.03 divided by 4, just because it'll make my life a little easier. 1.0075 raised to the 4t. Now we need to get to that exponent. So remember, the trick to getting to an exponent is to actually apply a log. So the base in this log has to match the base of the exponent. So it's going to be log base 1.0075 on both sides. So we have log base 1.0075 of 2 equals 4t. And then we'll divide both sides by 4. So in order to type this in, remember, we're going to have to do a change of base formula. So you'll do log of 2 divided by log of 1.0075, and then we'll divide all of that by 4. So let's go ahead and do that. Some of your calculators, by the way, do have the capability of doing a base, just most don't, which is why we have to do our change of base formula. So give me a second, because my calculator doesn't have that ability, so I am going to type this all in. It'll take just a second. Divide by 4. So we get approximately 23.19 years. And that would be your answer. So let's go on to another problem, just to kind of see some more. So this one's also a money problem. So once again, money problems are always going to be one of these two formulas. So a business purchased for $650,000 in 94 is sold in 97 for $850,000. So we want to find the rate of return for this investment. So we're actually finding the rate. Now it didn't say it was compounded continuously or anything like that. So we're going to go ahead and use our A equals P times 1 plus R over N to the NT. So A would be 850,000. Oops. P is 650,000. Our rate is what we're looking for. Our N, as they said, it was annual, so it's just 1. And time from 94 to 97 is 3 years. So we've got 850,000 equals 650,000 multiplied by 1 plus R, because R is just over 1, raised to the 3 times 1, or third power. And let's go ahead and divide, because that's usually our first step. So all those zeros will go away. So we've got 85 is divisible by 5, so that's going to be 17, and so 65, which is 13. So we have 17 over 13. That's what that simplifies down to. Is equal to 1 plus R to the third power. Well, this one doesn't require a log, so we just got to get rid of that third power by taking a cube root of both sides. So we've got the cube root of 17 over 13 equals 1 plus r. And my final step is to subtract 1 from that answer. So I'm actually going to go ahead and just type that in. So I've got the cube root of 17, oh, apparently I had something on my calculator, hold on. 17 over 13 and then we're going to subtract 1, so that gives you r is equal to, or approximately equal to 0.0935 or 9.35%.